Alright, looks like we're live. Hello everyone and welcome to yet another... Are we live? Are we live? Looks like we're live. Hello everyone and welcome to yet another Azuzin session. I hope you can hear me quite well. Hello, welcome. I go do big stream, Farcon, Trex. How do you pronounce your nickname? I'm sorry. I'm an idiot. So yeah, let's make a little bit of an announcement and officially start the stream. So a red circle live on Twitch. And what are we doing today on Twitch? We're programming in C. I'm gonna give the link to the Twitch channel where we're doing all of that. And I'm gonna ping everyone who's interested in being pinged. And there we go. The stream has been officially started. So today, we're going to continue working on a graphics library that I started some time ago. So I stopped it to do some Python development, and now I'm back. So you can find this library in here. So I'm going to copy paste it in the chat for anyone who's interested, and for people who's watching on YouTube. Maybe for lucky people who can watch this on YouTube, I will post that in the description eventually. Right, so the point of this entire library is that it doesn't really have any third-party dependencies, right? Because it doesn't really output anything, right? It's a graphic library that doesn't output anything. It renders everything into a piece of memory that you give to it, right? So you're supposed to allocate some piece of memory and then give it to the library and instruct what needs to be drawn, and it will just draw that into the memory. Then you take that memory, you interpret it as a pixels, you can save it into an image, or you can display it, or you can convert it, you can do whatever you want with it, right? So this library is only concerned with filling up the memory. It doesn't do anything but fill up the memory. It's up to you how then interpret that specific memory. Right, so, and today we're gonna continue developing this thing. So we have a lot of different demos and stuff like that. So let's actually take a look at this stuff. I think I already fetched the latest thing. Let me rebuild the entirety of the library. So it's going to build the tests and stuff like that. Right, so then it's going to build the demos. By the way, some of the demos that are actually like watchable, you can find on this website. Right, so for example, this library can render these kind of things, right? It can render rainbow triangles and circles with transparency. Right, here we just did a simple 3D example. We basically took a bunch of 3D points and we projected them on the screen and then draw the circles on their places, right? So this is what we did. The library also supports a little bit of like a custom text and stuff like that. It's capable of resizing the and transforming the images as well. So this is what it can do. And also we did like a 3D triangle thing. So the library itself does not really support 3D. You can see some 3D stuff in the examples, but the library itself doesn't have a support for 3D. This is something that we did in the demos themselves. Right, we wrote a simple function that just takes a 3D point and projects it onto the screen. In fact, we even looked into the math of how it is done. Right, so we even have a paper in the docs folder where all of that is explained, and we look into that on this stream, if I remember correctly, right? So this is basically the explanation, right? So you have a screen, you have an eye, you have some points behind the screen, and this is how you project those points onto the screen. And this is basically like the formula that we use to do this kind of stuff, right? So that's basically the formula, and we did all of that explanations like on the stream. So if you're interested in that, just go to the previous streams. So I think I'm going to put that in the description. I'm going to put that previous stream in the description as well. Right. So, but the more I do different 3D examples, the more I realize that maybe at some point I'm gonna move all of the 3D stuff into the library, so the library will eventually support that. So essentially on the previous stream, we did this 3D triangle, right? So let's actually take a look at that specific example, right? So here's the demo, here's the triangle 3D, right? And I can even run this entire thing, triangle 3D SDL. There we go. So by the way, the demos work in web, right? So they can work in a browser, and they also can work as a native applications outputting things into SDL, right? So this is how versatile the library is. Again, it is not concerned with outputting anything. It is only concerned with constructing the pixels. It only produces the pixels. It's up to you how you interpret those pixels. So we wrote like a simple demo framework that basically takes those pixels, and depending on how you want to display it, it either displays it in the HTML5 canvas or in SDL texture, or in some cases it can even print it in the terminal, right? So we can take a look at that as well. Right, so let's actually go to Olivet, and I'm gonna just do build triangle 3D. Let's do term. Right, there we go. So we're rendering that rainbowish triangle in the terminal. Of course, in the terminal we don't have colors, right, yet, right? So I do have plans to add color support. I think somebody in the Discord server actually like ported that stuff into the terminal colors, right, and stuff like that. So, but maybe we're gonna do that as well at some point. Right, for instance, we have squish. Yeah, there we go. So that's the thing that you can do. Right, it doesn't really matter. And essentially, right, the thing about this triangle, this 3D triangle, is that it can only work with a single triangle, right? So essentially, let's actually take a look at one more time at this thing. I'm gonna try to run it. Build triangle 3D SDL, right? So let's imagine, right, so here's the sort of like a pivot or axis, right? So it's rotating around a certain axis. If we take another triangle that is rotating around the same axis, but it's lagging behind that triangle for 90 degrees. So this sort of like, it forms a cross of triangles, right? So if we try to render a second triangle like that, that just like literally crosses or goes through the original triangle, it is not going to work properly, right? It is literally not going to work properly. So let me rebuild everything one more time. So and so it's actually taking some time. Maybe I should, it's fine. And triangle 3D SDL. So as you can see, they don't really go through each other. This kind of effect. And this is something that we're going to be concerned about on today's stream, because I think it is a very interesting topic, and people already saying that in the chat, the depth buffer, right? So we will have to explore what is a depth buffer, how we can use that, how we can extend the library to support the depth buffer, and stuff like that. It's going to be very, very interesting. So I'm not even sure if it's going to work out, but hopefully we'll see. We'll see. Okay, so we've got some subs, I suppose. Let me take a look. Valeni, thank you so much for resubscription for 16 months already. Thank you, thank you, thank you. ADM ______, thank you for 2 months. And Xayeto, thank you for 6 months. Pogi indeed. So let me take a look at the chat and see if there is any questions so far. Everyone just says hello. Later stream when we're going to be exploring another maybe math thing. Right now I don't really plan to do anything math intensive right now, so probably not today, but we have 2 later documents in the docs folder, right? And both of the documents were written on the stream, so we already had at least 2 later streams, right? So maybe we're gonna do more, because I found later is really useful for like visually explaining, right? And also showing the logic of actually of getting of sort of like reinventing certain formulas, right? I could have just write it on the with my tablet, but it's much more easier to do that in later. Right, so we can even take a look at some varicentric coordinates, and varicentric coordinates are going to be very important for the depth buffer, right? Aboba. Some people say aboba. Aboba indeed. Hello, hello, welcome, welcome, welcome. So let me go down. Everyone says a boba. Okay, so to understand how can we make the triangles properly intersect with each other, we need to understand how do we even draw that rainbowish gradient. You can notice that we have a rainbowish gradient, and it's actually related to how you can achieve the proper intersections of the triangles, right? So you can see that for each vertex, there's sort of like a certain color associated with that vertex, right? So with that vertex, there's a green color. Maybe I should actually get rid of the secondary triangles so it doesn't like stay on our way. Right, so let me reveal that. Ghosty X101, thank you so much for 4 months. Thank you, thank you, thank you. Okay, and if I do triangle 3D, there we go. So as you can see, you have color associated with each triangle, and as you go towards another vertex, the one color sort of interpolates into another one, right? And this is achieved through triangular interpolation, right? So essentially, we already have a document which explains that, right? So imagine that you have a triangle, vertex 1, vertex 2, vertex 3, and you have a point inside of the triangle. So essentially, we are calculating 3 values, u1, u2, and u3, which, if you sum them up, form 1. The sum of these values is 1, but each individual value sort of shows you the percentage of how close the point to that specific vertex. So if P is closer to V1, U1 is going to be bigger than U2 and U3, right? And also correspondingly, if it's closer to V2, the U2 is going to be bigger than these two, right? But in the sum, they form 1. So that means you can use these 3 values to mix up, for instance, 3 colors and achieve that specific gradient. So in this specific paper, we actually went through the logic on how to get the formula to calculate these values. So if we have 3 points of the triangle and a point on the triangle itself, this is the formula that you have to use, right? It's a little bit like big, but it's actually rather simple, right? So you don't really have to memorize it. You can always sort of derive it, or since it's already on paper, you can essentially just copy paste it, right? So, but how exactly you achieve this formula doesn't really matter. What's important is the meaning of these 3 values, right? The meaning of them, they are values of how close that certain point to one of the 3 vertices. The next thing we do, we iterate through each individual point on the triangle, right? So we iterate through each individual pixel on the triangle, right? And then if we mix up 3 colors using these sort of proportions, right? So U1, U2, and U3 give us proportions, right? And that's how we achieve that specific gradient. You know, what's interesting is that to make 2 triangles properly intersect with each other, we need to know the z value not only of the vertices, right? Not only of the vertices themselves, but we have to know the z value of each individual point on the triangle, of all of them, right? How can we know them? Well, we can know them the same way we know the color of each individual pixel on the triangle, right? Imagine that we have a z value instead of color associated with each individual vertex. What if we triangularly interpolate the z values instead of colors? Think about that. So that means we'll be able, through that formula, calculate the z value of each individual pixel of the triangle. So what we can do with that? We can essentially take an image where instead of pixels, we have the z values of each individual pixel. And then if we have this sort of image where each pixel is the Z value of the pixel instead of the color, is called depth buffer or Z buffer, right? We render two triangles and we render their corresponding Z buffers. And then we go through each individual pixel and we compare their Z values of each individual pixel, right? And we remove it. We just don't draw that pixel, we draw the pixel that is clothed according to the Z value. And that's how we achieve this sort of like a line, right, when two triangles intersect with each other. So, and that is called depth buffer, or Z buffer. And this is exactly what we're going to try to implement today. All right. So, let's go ahead and try to implement that, I suppose. Does it make sense? Hopefully that makes sense. So let's go to let's go to the demos, I suppose. Triangle 3D. Right. So here we draw the first triangle, right? And here we draw the second one. So what I probably want to do is go and introduce another function that, instead of interpolating the colors, will interpolate the Z values. But here's the thing. The Z values that we use in here, they're floats, right? They're essentially floats, but our pixels are unsigned integers, 32-bit unsigned integers, right? 32-bit unsigned integers. So how it feels like I need a second type of the canvas. So we have a notion of a canvas, which is basically a view on the pixels, and each pixel here is unsigned integers, 32 bits. We need another canvas, something like depth, right? So maybe we can call it depth, which is basically floats. And the reason why I want to have this kind of thing is because I want the rest of the operation work similarly to how it works for the canvas. For example, for the canvas you can do a sub-canvas, but unfortunately in C, right, you'd have to have a second version of the sub-canvas that now accepts the depth, so you have to duplicate the code, right? In a language where we suppose generics, we would have something like, I don't know, T, and T would be like a pixel of this entire thing, and depending on which one do we want, right, depending on which one do we want, we would either have U-in32T or the float one, right? And for instance, subcanvas wouldn't really care about specific internal type, it would accept T, right? But unfortunately in C we can't really do that because C is dumb, right? So we have to do something else, and I think I know what exactly I'm going to do. I'm gonna literally use Olivet's canvas as it is with U-in32 values as the Z buffer. I'm gonna use that as the Z buffer. So, and I'm basically going to store float IEEE 754 values in a U-in32 because floats are also 32 bits, right? So essentially I'm going to be using this thing as a storage for the Z values, but then I'm going to be reinterpreting these U-in32s as floats, right? And that way all of the things that already work for the canvas, they're also going to work for the Z buffer. So I'm going to do that until I come up with a better solution, but to be fair, I'm not even sure if I can come up with a better solution, so it's probably going to be like that for now, right? But it's actually kind of cool. That means sub-canvas is going to work, just constructing a canvas is going to work, fill is going to work, rect is going to work. For instance, you want to fill a specific rectangle with certain Z values. You would be able to just use integer representation of a float, right? And you just fill it up because it doesn't really care, it just can fill them up. So maybe it's gonna be, I think it's actually kind of cool solution for C language. Cast hell, I don't think it's gonna be a cast hell. Right, so look. Essentially, how do you reinterpret float as an integer? Right, so let's actually include stdio, let's include an integer, and then I have a value, let's put something like 16. It will get float and convert it into integer. It will literally change the internal representation of this thing. And then if I want to print this thing as a float, so basically I converting it back, right? So as you can see, I take float, I cast it, basically convert it to integer, and then I convert it back into float. I'm not gonna get the original value, right? So gcco main.c. Right, so if I try to run that, as you can see, we lost for 20. We lost for 20. How can we store a float inside of integer, but without losing any information about the float? How can we do that? Well, so we can take a pointer to x. Now we're not talking about specific value of float. We're talking about pointer to that value, right? So you can think about it this way, right? So you have a memory. So this is basically the memory. Somewhere here you have x stored, and it takes 1, 2, 3, 4, right? So it maybe takes this kind of thing. 1, 2, 3, 4. Well, it takes basically like 4 bytes or something, right? So here's the x. But then when I get a pointer to x, I basically have another value in the memory, right? I have another value in the memory that points to that thing, right? So it points to that specific thing. You see what I mean? Right, so now we're just keeping that value as it is in the memory, but we're looking onto that value through this specific pointer. So we have this specific pointer. And then we say, okay, take that pointer, but now this is a pointer that doesn't point to float. It points to uint 32. Okay, so we converted this value, not this one. In fact, like we didn't even convert it. We just hinted the compiler that just basically interpret the bits behind that pointer differently. And then when you basically dereference it, you will read this value not as float, but as integer. It's going to be the same bits. It's going to be the same bits, but it's going to be reinterpreted as integer. And then we can basically try to print it, right? So we can do something like this. There we go. So print, I forgot to put this thing, and there we go. So this is how essentially 69/420 looks as an integer, right? And then you can reinterpret this entire thing back into the float, and none of the information is lost. I mean, the little bit of information is lost, but this is probably due to the printf implementation itself, right? So, and this kind of technique is called type punning. So if you never heard about this technique, I really recommend to check it out. So it's used very actively in languages like C and C++. I'm going to actually post that in the chat for anyone who's interested. And where is my description? So here it is. So this is a type punning. Right, and this is literally what we have to do, right? So we just have to take the pointer to a certain thing and reinterpret it. So in terms of like a float, like in terms of the Olivet's, right? So if we're talking about Olivet's canvas, right? So this is OC. Then we'll have to take Olivet's canvas, Olivet's pixel, right? And then we take a certain pixel, we take a pointer to that pixel, then we're reinterpreting that pointer as a pointer to float, we dereference that pointer, and then we save it as 69/420. So if you're talking, when you say like a cast hell, if you're talking about that, to be fair, this is not that much of a cast hell. So if you do understand what exactly you're doing, it actually makes a lot of sense, right? So you have a pixel, which is 32 bits. You take a pointer to that specific pixel, and then you say, okay, you point at float, not uint32 now. You dereference it, and you put a float in there, and there you go. You successfully stored a float value into uint32. And that's basically it. So, and then you can just use the rest of the operations like, let me see, all of that's like fill, right? Like fill, and you can fill up the z buffer with zeros, for instance, right? And by the way, the floating point 0, so which is also quite convenient. Also, quite often people, I remember that some of the game developers, by the way, they can construct a floating point number by doing the hexadecimal literals. And I'm not even joking. So some of the game developers, they've been doing this bit hackery for so long, they can just do, okay, so I need the 69 for 20. So it's going to be positive, so it's going to be this, AF, something, something. So I'm going to pad this around. And they basically start constructing the floats bit by bit in their memory by using hexadecimals. And they say, oh, okay, this is a 69 for 20, for instance. And one of such people, by the way, I think Jonathan Blow. I've seen Jonathan Blow just like doing this shit like that. He was just like, he needed a certain representation like a floating point, but as an unsigned integer, and he just started to do hex. So it was just like, holy fuck, what the fuck? Right, so basically constructing the IEEE 754 floating point integer, floating point number, like, but manually. Holy shit, yeah. It's kind of interesting, but I'm not at that level, so usually if I need to do something like this, I just like write a program that just gives me that value, just reinterprets the value and just like prints it like that. I think it's a little bit easier, but if you can do that right in your head, it's probably faster, right? But that's insane. But anyway, so this is how we basically going to approach the Z buffer, right? And what I want to do. So we already have a function, triangle 3, right? It takes 3 points and also 3 colors. And it basically draws the triangle interpolating the colors between these 3 colors. So I want to rename this thing to C to indicate that it's a color, right? So let's actually go to triangle 3. And I'm going to put C in here, maybe I'm going to put space. So the reason why I want to do that is because I want to create another one, which is going to be called triangle 3Z, right? And instead of taking colors, right, so as you can see uint32, it is going to take floats, and each of these things is going to be Z1, Z2, and Z3. Right. So, and essentially what it will do, it will interpolate the Z values between these 3 points and store them into the original canvas, but as uint32s. So you have to sort of like know what exactly you store in there, right? So unfortunately there is no like proper type safety in this particular situation, but it's C. What kind of type safety you were talking about, right? All right. So let's actually go to triangle 3C, right? And then I'm gonna just put this thing in here. I think I'm going to copy the implementation of triangle 3C, and I'm gonna just replace blending of the color with blending of the Z values, right? So here we have 2 loops, basically two nested loops. 2 blocks of 2 nested loops, if you will, and this is because we arrange the triangles by splitting the triangles into 2 triangles, right? Because it's a little bit easier. Okay, so we have, where is that? So Z1, Z2, and Z3, and in here I do barycentric coordinates, and then I construct the color. I don't need to construct the color, I need to construct the Z value, right? And the Z value is going to be basically a mix of Z1. I said Z1 plus Z2, Z2 and Z3, but mixed up with certain proportions, right? So with U1, U2, and U3. But here's the catch, right? So barycentric coordinate function doesn't really work like that. It doesn't return you the floats, it returns the integers. So essentially it gives you value u1 and u2, and to get the value from 0 to 1, you have to actually divide them by determinant, right? So like so. So this is basically the specifics of that specific function. The specifics of that specific function. And u3 is equal to that minus u1, u2. And you have to divide it by that one more time. And this should give you the basically the you know, the blend of 3 z values. So we'll get some subscriptions. So let me see. So Rebelander, not sure if you're able to get the funds yet, but hopefully. No, I don't get any money from this thing. I'm sorry, but thank you so much for the Twitch Prime. Maybe eventually. Right now, I'm basically using subscriptions as the way to moderate people, right? So because it's super easy for me to just, you know, put a subscription mod, right, and get higher quality questions because we're on Twitch. Okay. So GhostX101, thank you so much for 4 months. Thank you. Greg Inc., thank you so much for tier 1 subscription, and Kayokami, thank you so much for tier 1 subscription, and THP Bugstar, I hope I pronounced your nickname correctly, thank you so much for 2 months of subscription. As soon as you'll get the money, you'll be rich. I'm not sure if I'll ever get this money, to be fair. The longer the war goes, the more I feel like it's just like probably at some point Twitch is gonna just take all of those funds and send them to Ukraine. I'm quite confident, maybe after a year or so, which I'm actually super happy with, right? So that will be actually a very good way to spend this money, in my opinion. Maybe they should actually do that. That's actually very interesting. Just basically take like all of the revenue of all of the Russian streamers and just send them to Ukraine. That's actually really funny. I bought Twitch sub for access to the Discord, but I think it'd be cheaper for me to give money on Patreon due to annoying technicalities. Feel free to do so. Feel free to do so. Isn't it dangerous talking like that about Ukraine while you're in Russia? It is dangerous, but you have to remember that they don't speak English. So, they don't speak English. So, the thing is, my bet is that they don't really care about what's going on in the English-speaking sort of information sphere. Furthermore, they didn't even block such websites as like English CNN or BBC, right? They blocked all of the information like news outlets that report news in Russian. They blocked all of them, but they didn't block anything in English. And this is really funny. So right now I'm not using any VPN, right? So let me try to Google CNN, for instance, right? CNN, international, breaking news, stuff like that. So let me try to open it. I wonder if I can do it. Did they actually ban that? Oh no, I think they actually banned it. Okay. The CNN seems to be banned, at least for now. Very well then. I guess they're coming for me as well. This is gonna be the last stream. Anyway. How are we gonna be doing all of that, right? So I'm gonna just set this thing like this, and then again, what I need to do, I need to save float into U32, right? So I take Z and I take a pointer to Z, and then I say, now it points at U in 32, and this is the pointer now. And then I dereference it and I read the floating point value as the U in 32, and this way I'm saving all of that information there. Right, so this is basically how we're gonna do all of that. And I need to do the same thing for the second triangle here as well. So let me just copy paste this entire step, and there you go. Okay, good. Right, so let's actually build everything. Okay, so we also, first thing we do here, we also sort the points in a certain way, because we traverse them in a certain way. Right, so maybe I can actually do something like query replace C 0 9 like so, 0 9 like so, and then replace it with Z1. And it didn't work because why? I didn't use the proper function, right? So I should have used something like this. Boom. Can your Vim do that? I don't fucking think so. Your Vim can't do shit, mate. So let's actually recompile everything. Oh. So, oh yeah, I renamed the function, so now it's triangle 3C. Let me actually quickly go through all of these things. Right. This is really weird. I should have actually used... I can't use Chaturina for some reason, by the way. I don't know why anymore. Because Chaturina website doesn't work for me anymore. I wonder if the Russian government actually banned Chaturina, or there is something wrong on the Chaturina side, but the Chaturina responds with invalid response. I have no idea why. So, and usually the blocked websites, they basically hang. Right, so, and this one doesn't really look like it hangs, it's just like it says that something wrong on the website part, but I don't really know what exactly, it's just so weird. And I need to relog in with my Chaturina, and I can't do that because of that problem, and just like I can't use Chaturina, unfortunately. It is what it is. Also, it's a little bit hard in here, so let me open the... It works in Germany though, well, I'm really happy that it works for you. I think Fourth just sanctioned Russia, so I think that's what happened. Oh, okay, so Agaduk, you're also in Russia right now, so it works for you. Okay, that's very interesting. So maybe it's something on my side. Wait a second. Just a second. What if I use Firefox? What if I use Firefox? Is it something with my browser? Chaturina.com. Okay, so it's hanging. Oh shit, it works. It works in the Firefox. It doesn't work in the Chromium. Wait, what the fuck? Okay, that's very interesting. So maybe I can... Thank you, Chromium. Very cool. Maybe I have an old Chromium, but it's such a weird... Like, I don't experience this kind of thing on any of the websites except Chaturina. Alright. So, let's continue. So, what are we going to do here? So, we already recompiled everything. So, I'm going to go triangle 3D, right? So, this is a triangle 3D. And basically, I think I need to construct another sort of canvas, right? So, here I have pixels. Right, let's introduce another thing. We're going to introduce ZBuffer, which is going to be just two-dimensional array of the same size, right? Of the same size as the canvas. Right, and in here we are constructing the canvas of the pixels, and let's try to maybe construct the canvas of the ZBuffer. Let's call it ZB. Olivet's canvas, and here we're going to have ZBuffer, but we'll have to reinterpret it as uint pointer. Width, height, width. I can load Chaturina in Chrome. I'm in Ireland. I mean, I already have Chaturina. In fact, I do not download Chaturina from Chaturina website. I built this Chaturina myself from scratch, from the source code. Yes, that's how hardcore I am. Yes, I build my own shit, even though I'm on Debian. In fact, that's precisely the reason why I built my own shit, because I'm on Debian, right? So on Debian, it's impossible to have the latest software, especially on the old Debian, right? So if you want to have more or less fresh software, you literally have to build it from scratch. So that's precisely why I do that. So, like this is something that I have to do, right? It's not like because I want to flex. It's just like, yeah. Anyway, so I want to fill the Z buffer with zeros. And this is what's cool about this entire thing, right? So I fill it up with 0 integers, and I know for sure that they can be interpreted as 0 floats as well, because IEEE 754, all bits 0 is a 0 value, right? So which is quite convenient. Anyway, so we have a Z buffer in here. So we have original pixels in here, and then the Z buffer. Okay, so let's actually try to render the triangle and also its corresponding Z buffer and see how it's going to go. I think it's going to be rather interesting. All right, so I think, so this is a 2-dimensional point, so I can't have their Z values, so the Z values are somewhere here. Okay, so let me take this thing and just like separate them. So this is a vector 3 v1, right, then we're going to have vector 3 v2, so this is another one, v2, and vector 3 v3. Make vector v3. There we go. So here are 3 vertices of the 3-dimensional vector, right? They're constantly rotating. Then we are projecting these 3 vertices onto the screen. So these coordinates are in screen coordinates now. And then we're drawing a triangle, interpolating between 3 colors. And now, another interesting thing. Maybe here we're going to do triangle 3Z, which renders into the Z buffer, and we're using the, yeah, I think we have to use the projected values. Yeah, so I'll probably have to move it in here. All right, we use the projected things like so, right? But instead of the colors, we have to use V1Z, V2Z, V3Z. There we go. So here we are rendering the pixels, the color. This is our color buffer, and this is our Z buffer. So here we store the information about the Z. Okay, so and now it would be nice to somehow maybe visualize that Z buffer. Like I would like to see how it looks like, at least. So the only thing I know here is that it has values like maybe from 0 to something else. So initially we filled it up with zeros, right? So everywhere where we don't have a triangle, it's going to be 0. And then where we have a triangle, the value is going to be probably from 1.5, oh, it's also, yeah, it's going to be value from 1 to 2. This one is actually kind of interesting. It's going to be value from 1 to 2, and I want to see that. I want to actually see that. So let me see. We can try to maybe use the Z value. Use the Z value in the color value. Essentially, if the Z is too big, we can make certain like corresponding pixels darker. That's actually a pretty cool idea. And if they're closer, we can make them brighter. You know what I mean? That's actually very cool. So let's give it a try. So let's actually iterate zy0. So we're gonna iterate by rows, and then we're gonna iterate by columns. I really like this idea. So it's gonna be, so we can have sort of like a shader effect, right? You know, you can create some maybe like a fogish effect, if you know what I mean, right? Some sort of a fogish effect. So and all right. So here I do Olivet's pixel, and I take a pixel from OC, so it's basically X and Y, and this is my original pixel, right? Or maybe I'm gonna call it a color, right? So it's a color. And then I need to extract the Z value out of the Z buffer, right? So I'm gonna do literally a similar thing, but instead of OC, I'm gonna do ZB. Right, but then it's U-in32. I have to take a pointer, I have to reinterpret it as a float, and I have to dereference it. Right, so a little bit of a cast, but I wouldn't call this a cast hell. Right, so Yeah, you see? It might be daunting if you never dealt with this kind of bit hackery. I do agree with that. But once you kind of get used to that, it actually makes sense, right? So, you know, maybe programming a little bit in assembly kind of helps to deal with this kind of thing. Actually, programming, like having experience in programming in assembly is actually generally useful, because as soon as you know how to program in assembly, you kind of never stop programming in assembly, you know, because you continue programming in assembly even if you're programming in other languages, right? You programming in C++, for example, and since you have assembly knowledge, you're already programming in C++ differently. You're sort of treating C++ as a preprocessor for assembly, and that actually affects the decisions that you make when you program, and actually gives you a deeper understanding into how your program works, and you can do a lot of more interesting things, right? So essentially, assembly programmers, they always program in assembly no matter what language they're programming in. They may be programming in JavaScript, they're still programming in assembly, because they may be thinking how the script is going to be JIT compiled to the actual assembly, right, and make decision based on that or something like that. I don't know. Anyway, so here we kind of know, right, that Z has to be from 1 to 2, right? It has to be from 1 to 2. But if it's less than 1, that means this is a pixel that does not belong to the triangle. So I think we have to do something like this. We have to only look for z's that are greater or equal than 1, right? Because if it's less than 1, that means it's probably 0, and that means it's probably the one that is not part of the triangle, that is not part of the triangle, right? And the value that we actually care about is z minus 1, right? Since z itself in here is a value from 1 to 2, by subtracting 1, we get a value from 0 to 1, which already can act as an interpolator, right? So that means we can blend two colors, right? And we can essentially blend this color, right? We can blend this color with, for instance, black, right? Right, something like this. Blend color black with this interpolator. But as far as I know, we don't really have such a function that can mix the colors this way for us. Yeah, you can only mix it like that. We have mixed colors, but you have a thing that essentially mixes 3 colors. So you know what I'm thinking? I'm thinking I'm going to construct the following thing. I'm going to take z minus 1, then I'm going to multiply this entire thing by 255, effectively making this thing right from 0 to 255, right? So this value is from 0 to 255. Then I'm going to cast this thing to in32t, making sure that it's integer, right? So now it is integer. Then, so this is basically like this value. Now I want to shift it by how many? So this is 1 byte. I want to shift it by 3 bytes. Each byte is 8 bits. So this is what I want to shift it by. And this is the value, right? So this is the value that I want to mix with the original pixel. Right, so let me take a look at the blend. So I want to blend this pixel, like so, with this color that we constructed, that is based on the z value. Right, and in fact, I think that is it, and it does not require any of these values. Yeah. So essentially what we do here, we render the triangle, then we render its z buffer, then we modify the color buffer based on the z values, making the further away pixels darker. That's literally what we do with the z buffer. So this is something that when you program in OpenGL, you would probably do that in a shader, right? In the shaders, you usually have the access to the Z values of the pixels and whatnot. I don't know if it's gonna work. I never tried that, so let's actually see. It's gonna be rather interesting, I think. So it's taking some time to program, and I think using Twitch's chat instead of Chat Arena actually slows down my entire computer. So I should not do that. And let's actually do Triangle 3D, SDL, and does it work? It feels like it doesn't work. Very interesting. Alright, so what if we... Ooh, so it's a 0. Blue looks darker than it was, right, but it's actually have to be more than that, I think. Right, so let me try to remove this block of code, right, let me try to remove this block of code and see if it actually does anything, right, maybe it doesn't do anything. Right, so let me do build sh, because it has to be a little bit more dramatic than that. It has to be more visible, I would even say. Right. Okay, the blue kind of does look darker. It does look a bit darker, but not too much. Yeah, it does look darker, but it's like the green should also look darker as well. When it starts rotating, it should also look darker, but it doesn't, right? Which is rather interesting. So the thing I want to do, in fact, is probably let's actually literally assign those values to the pixels. Right. Let's just assign these values to the pixels and see if it has this gradient. We can take a look at the gradient that is used in there. If I go to semicolon, or maybe we can do something more different. I wish it would compile a little bit faster. My computer is so slow. I just can't. Okay, it's basically always dark, no matter what. It is always dark, no matter what. So what I want to do in here, in fact, is just take this value and just save it, maybe like this. Okay, let's just preserve this value. We're preserving this value. And I just want to take a look at the values of the Z buffer. That's what I want to do. So let me try to do the following thing. I'm gonna print them. I'm gonna literally print them. I just want to see them. Sometimes it's really difficult to do, just to see things. Right, so I'm gonna just comment it out, printf, and I'm gonna create a new file. And after I printed them, I'm gonna just simply exit. Right. Alright, so I just want to see something. We'll be able to see something, hopefully. Okay. It's so painful. Okay, so we can see something, but it's just. It doesn't even die. So I should have actually reduced the resolution. It doesn't freaking die. Okay. I should have decreased the resolution. So let's make it around something like this, so it's at least readable, right? So hopefully everything is based on that resolution. I think it is. Now I want to change some of these things. We're only going to build the triangle 3D, right? We're not going to build anything else. And in fact, I think I'm not going to build any assets or anything like that. Just only build the triangle, right? So only build the triangle. So hopefully that is going to be a little bit faster. And of course, some of these things are not, you know, working. So this is going to be stdio. And in the build, I want to build only at the SDL version. We're not going to build any other things. Okay. All right, this is what I wanted. Thank you very much. Okay. Okay, so we can actually see the triangle in the Z buffer. So I just printed the Z buffer, and we can kind of see the triangle. But the problem is that we print too many things. Right, we print too many things. Let me see. So let's actually print only, I don't know, 2 digits after the dot, after the period. So because I wanna be able to see some of them. Can I just have a half of that? Right. I just want to see the actual values and what they're equal to. Yes. Okay. So this is what I was talking about. Cool. So they are in fact from 1 to 2. This is the only thing I wanted to confirm. They are from 1 to 2. And they form the triangle. Can you see that? Right, so they actually form the triangle. This is actually very cool. Right, so they are in fact working. But what's funny is that they kind of... Why do they have 1 in here and they change... So, if I remember correctly, they all, at that specific point of time, they kind of have the same Z, don't they? Except that one. Right, so this is Z1, Z1, and then this is 1.5. Why is Z here 1.5? It feels like we found some sort of a bug. Right, that's what it feels like. Because I'm pretty sure if we print these values like so, they're going to be literally 111. Right, they're going to be literally 111. So I just want to see that 1.5 1. Well, yeah, they're 1.5 1.5. That means that these values have to be 1.5 1.5. This feels like a sort of a bug. 3Z. And let me see. Is this actually a bug? Maybe. Maybe it is actually a bug. Right, because if this is Z1, U1. Thank you so much for all of the subscription. Thank you, thank you, thank you. I'm sorry if I can't really acknowledge everyone. I'm a little bit busy right now. Right. Okay. So let me see. Do we have any bugs in here? I don't think so, because I already done this kind of stuff before. Right. So, det minus. It's U1, U2. Right. So this is Z. And in terms of, yeah, so in terms of color, we also have this kind of thing. Interestingly, maybe I can just do something like this, right, and divide all of that a little bit later. It should work. It should actually work, but it doesn't. Right, it doesn't work. And what the hell happened here? That's really weird. Okay. Wait, was it always like that, or did I accidentally remove it? Yeah, I probably accidentally removed it. Okay. So 1.5, and this is 1. This is absolutely incorrect. This is absolutely incorrect, and I don't really know why. I printed them like this.
Is that because maybe I'm taking barycentric coordinates incorrectly? Or maybe there is some sort of overflow. Yeah. So I'm just thinking, how can you... Why? Why is it like that? What if I do it like this? Right, so I'm gonna convert them to floats right away. Right, so this is 2, and this is 3, and 3 is gonna be basically a determinant minus u1 minus u2, like so. Right, so then later I can mix them up a little bit easier. z3, v3, right. And let me put this entire thing, right. So I probably need to think how we, like, of this instead of 1.5, even though all of the 3 should be 1.5, right? So if this is the proper triangular interpolation, both of, like, all of the 3 values have to be 1.5. Like, I have no idea how to properly debug that yet, right? So I'll have to think about that, because, like, I don't see any mistake in here, right? Unless there is a mistake in barycentric function, but we went through that thing several times quite thoroughly, right? So I'm quite confident that this is, like, a correct thing, right? So it's just because we've done a lot. So I don't know, like, I don't know where exactly the bug. So let's make a small break. Oh my god, the Twitch chat is so slow compared to Chatterino, it's just unbearable. Alright, so I'm gonna make a cup of tea, and then we're gonna continue. Alright. Oh shit, yes, thank you so much. Right, so the... freaking C. I see. Thank you so much, Luke Lane. Yeah. Alright, I'm gonna actually mention that after the break, because I usually cut in here, right? So it's... yeah. It's so annoying, right? That... yeah, I should use, like... instead of C, we should use more strongly typed languages with some sort of, like, a generics, right, or some sort of templates. But any alternative to that, upon fixing the problems of C, they introduce a shit ton of other problems, right? It's just like, oh yeah, you have this problem in C, so you have to use C++ or Rust. No, I don't want all of the craziness that C++ and Rust bring into my programming. I just want these small, specific problems, very small, very little specific problems to be fixed, and I don't need a whole C++ for that. I don't need a whole Rust for that. This is the most annoying thing. Like, I know that in other languages, these kind of problems are non-existent. But for some freaking reason, other languages introduce shit ton of other problems that I don't care about. Like, why? Just take C, take all of these small little annoying problems and just fix them. Don't touch anything else. Don't add all the craziness. Don't do, like, don't defend shit ton of PhDs on types and some other stuff. Just take C, fix it. No, not functional program. No. Take C and just fix those things. Nobody does that, unfortunately. Anyway, so let's make some break. Okay, so you guys have fun. Ну що? Добрий вечір, друзі. Why did I close that? I should have actually... 4 minutes, I think. I think 4 minutes is gonna be enough. Maybe even 3 minutes. Where's my shit? Oh, because I'm focused on a completely different thing. 3 minutes soon. Anyone have any questions? The Ukrainian? Well, I tried to, but my pronunciation is actually kind of fucky. Fucky-wucky. Добрий вечір, дуже. Hi. I wonder if you can understand Ukrainian. Чи розумієш ти мене? Чи ні? In advance, for Ukrainians, I'm really sorry for my pronunciation. Ukrainian is not my native language, so I'm really sorry if I fuck up the sounds. Are you using OpenGL? No, I'm actually rendering pixel by pixel. You do understand me somewhat. I see. It's Ukrainian, but that was really Belarusian. Oh yeah, so here's an interesting thing. What I noticed is that Belarusian is it's like Ukrainian, but this sounds like they more Russian, which is kind of weird. Ukrainian, but probably. Are you still in Russia? Well, yeah, I'm still in Russia. In the middle of Siberian forest, near the border with, I forgot, Kazakhstan, Mongolia, and China, simultaneously. In Russia, on the south, there is a very interesting point, the point of intersection of Russia, Kazakhstan, Mongolia, and China. There's like a little point. I near that. In the middle of where? Now, there is an accent difference between Croats and Serbian. It's immediately obvious. Oh, that's a very interesting. You know, there was such an accent difference between Ukraine. There is a huge accent difference between Ukrainian and Russian, like huge. And not only accent, there is a huge difference in vocabulary and a little bit of a difference in grammar, right? But as far as I know, Russian and Ukrainian share only like 68-69% of vocabulary. So the rest are just like different words. Not Novosibirsk, no, still Novosibirsk. But Novosibirsk in the middle of forest, isn't it? So Ramon, what's up? Okay, so I'm gonna go take my tea. Stealing your tea. 2 minutes. Right. This is my tea. said an introvert party stays there. It's very ominous. Thank you so much for all of the subs, by the way, people. I really appreciate that. So let me see. Ghostex, Greg Inc., Kayokami, TH Baxter. Okay, Fast Magic 47. Haven't seen you in a while. Thank you. I haven't seen you in a while as well. Zork and Hammer, thank you so much for 47 months. Holy shit, thank you. Charles Bukovsky, thank you so much for 3 months. Are you still in Russia? Yes, I'm still in Russia. I already answered that. And Jewel, thank you so much for 8 months of Twitch Prime. Just a second, I forgot to close my door. I'm just afraid that my neighbors can hear me. TIL interpreted int as float via pointer. Yes, it is actually a very useful trick. You know, there was a border with China on that region. Yeah, there is. It's actually very small. It's like very narrow, but still there is. It's actually a very interesting place, like a really intersection of 4 countries simultaneously. Okay. So just chilling, chatting with chat. Okay. What are your honest thoughts about Rust for game development? I have no idea. I'm not a game developer. So really tell us where you are. No concerns about draft. I mean, I'm in Novosibirsk. Chatting with chat. I'm pretty sure KGB knows where I am already. It's a matter if they can actually break into my apartment. So, but why would they spend so much effort of breaking into my apartment? I'm literally nobody. In between C, C++, C#, which you love the most? I hate them all equally. Hello from Buryatia. Hello. How is it in Buryatia right now? You tried Carbon? No. Do you know nobody that speaks English in Russia, so you're FBI agent 100%? Sure. Do you prefer milk or dark chocolate? Neither. Did you move so close to the border just in case you need to leave Russia? No, I was born there. So when I was about to spawn into this world, like I had a choice where to spawn in Russia. So yeah, I chose the closest one to the China border, just in case I have to escape. You're born in the border, molded by it, yes. Why doesn't Haskell have a good IDE? Because nobody programs in it. Why do you need a good IDE for a language that nobody uses? Just think about it. Just think about it. Sorry. Go. Have you been into any of the close countries? Never. In fact, I've never been outside of Siberia in my entire life. I was born here and I lived here for 30 years. Everything I know, everything like all the skills I have, I possessed over the internet. And I'm not even fucking joking, while sitting in Siberia. That's the marvel of the internet. Isn't that cool? Like, I've never been in my entire life. I lived on this freaking for 30 years. I've never been outside of Siberia. Right. And I learned all of that just like over the internet using a shitty laptop. Right. That's sad. Is it sad? I think it's kind of cool. It just like demonstrates that you don't really need much, right? So all of your excuses for not starting, like, learning certain things are just excuses. You can learn, like, pretty much anything while having a shitty laptop and connection to the internet, right? So it's just up to you. But maybe some people hate that, right? Because that sort of takes away excuses from them, right? You know what I mean? Pretend knowing something about programming WTF. Some people have ADHD. Yeah, it's true. So it makes it kind of difficult to learn things. That's for sure. Да, чё по-русски говоришь, а, сука? Sorry. Alright. You're working in tech nowadays. No, really. In fact, I don't really like tech. It's kind of... It's like, it feels like a hamster wheel, to be fair. It's just like, they always need to, like, do everything faster and faster. They get, like, they put tighter and tighter deadlines, and it's just like, there's no room for improvement, there is no time to learn anything, and it's just like, just hack together as quickly as possible because we have to get on the market. Just like, we have to get on the market, and it's just like, it's so fucking crazy. I just hate it. My god, it's just, no. I might change career and studying whole. And what's interesting is that there's like a lot of actually great developers, like seriously considering leaving this industry, and also some of them actually doing that. And you know what's interesting is that this is actually dangerous for the industry. At some point, this industry will scare away like all people who actually produce the value, and we won't have anybody who produces the value, and the industry is gonna like eventually stagnate. So by acting like that, by not respecting the developers, they essentially killing themselves, right? So yeah, the industry essentially killing itself. I wonder what's gonna be in some time. After 5 years in industry, I feel already disgusted by it. Yeah, same. That's one of the reasons why I'm a streamer. Like I can't stand it. I just can't stand it. Like the Roman Empire. Yeah. Do you plan to travel outside of the country? That's a good question. When all of that shit is over, I think I will consider traveling outside. Right now, I just don't really want to go anywhere. Yeah, this is a graphic library from scratch. Alright, let's maybe continue. Okay, so while I was on a break, chat actually noticed what was the problem. Alright, so triangle 3Z. So the problem was I'm swapping two floats, but I'm passing integer as type. So if we take a look at how swap works, right, it's a macro, and it's more of like a generic macro. And we pass the type because we want to create a temporary variable in here. Right, we want to create a temporary variable to store something there and stuff like that. And essentially, the problem here is that we've got a float and we assigned it to integer, which resulted in loss of a value. In all fairness, there should be a flag that basically throws a warning when you do something like that, and I think that flag is called conversion. W conversion. I think, I'm pretty sure. GCC new W conversion. Why is it called new? The behavior of the conversion has changed. Its original purpose was helping to translate old C code to modern system by identifying places where adding function prototypes. The new conversion option warns for implicit conversion that may change value. This is what I want. This is not what we deserve, but this is surely what we need. So, and it's not part neither all nor extra. Okay, so let me take a look. So I want to go back to the original implementation, right? So it's going to be triangle 3z, right? Triangle 3z. I want to go down in here and I want to get rid of all of this stuff because it's not particularly helpful. You want that, u2 det, and det minus u1 minus u2 det, and I'm going to copy paste this entire scheiße. Alright, so, and I'm going to try to compile it, and it should compile without any warnings, without any errors and stuff like that. And now I want to add W conversion, and hopefully this entire thing should throw a shit ton of warnings. Okay, that's very cool. In fact, it threw more warnings than I anticipated, which kind of... okay. Alright, is there only conversion for... damn, bruv. That's a lot of stuff. I'm definitely not going certain... oh, look. So there's also sub-warnings. So W conversion enables a bunch of things, but what we care about right now, I think, W implicit float conversion. I think. Do we care about that? But maybe not. Let me try to find... So here is the Olivet's swap, and there is implicit conversion, float conversion. Yes. You know what? I'm gonna enable only float conversion and not that thing. Right. And as you can see, it now points at all of these cases. I should have enabled that long time ago. Okay. That's quite a dang compile option. Yes, it is. It is in fact very dang compile option. So, okay, I'm definitely gonna keep it enabled, and probably should enable more of such options, right? Because, like, yeah, it could have saved me so much time. It didn't. Okay, so I'm gonna do float. So this is float, and this is float. There we go. So, and there's a couple of other warnings that I also want to address. So this is Z, and what I probably want to do, so this is the Z values, right, and they're floats. So what is it complaining about? I'm not quite sure. Oh, it's Y. So it wants me to probably do something like this. Is that what it wants? That's disgusting, not gonna lie. So there is some sort of yeah, it's useful for some situations, but it's not useful for other situations. So it's kind of difficult to find that middle ground, you know what I mean? Some sort of a middle ground. So I'm probably gonna disable it for now, but I'm gonna put it to do. Enable W conversion. We can't enable it right now because it produces too many warnings to fix on the stream. I fix it later. I fix it later when I have time. Right. So basically I'm gonna make a cup of tea. I'm gonna sit in my IKEA chair that I bought before the IKEA actually left Russia. Right. Then I'm gonna be sitting in that chair, drinking my tea, and fixing all of those warnings. That's what I'm gonna be doing. And waiting for KGB to actually mobilize me, of course. That's the ultimate Russian aesthetics. Nice chair, but I think I didn't buy it myself. It was already here in the apartment, so it's not even my chair. But I'm pretty sure it was bought before. Alrighty. Okay. So this makes chair vintage. Yeah, it does. Look at that. Look at that. It's uniform across the entire thing. Isn't that amazing? I think it's freaking amazing. Okay, but thank you so much, whoever said that in the chat. I don't remember your nickname, but I'll always remember your help, right? So we actually fixed that. So now let's try to apply the Z buffer, right? So I'm gonna remove that, and then I'm gonna remove that. And essentially what we're doing with the Z buffer, we're trying to apply it as a shadow, right? So let's actually see how it is going to, well, I mean, we can't recompile this entire thing. So this is V, and this is going to be basically the gradient of dark. We can't really see shit in this mist, but this is primarily because we're printing too much stuff. Right, can we... so this is kind of funny. You know why? Because we're using very small resolution. Alright. So that's very cool. We can't see much stuff. Let me see why. Okay, so this one is going to be from 0 to 1, then we multiply it by 255, and then we turn it into black. And it's not particularly helpful, I think. What we should do instead is, I think, mix it with some certain color, right? For instance, all white, right? Maybe that is going to be helpful. And yet again, it is not producing that much of a variance, I would say. Yet again, is something weird. We have to investigate this thing one more time. 40 and 30. Right, so I want to print the value, the Z value one more time. Okay. 2FZ, printf, new line, exit 0. Right. So, and in fact, I want to rotate this entire thing a little bit, right? So I'm going to put 1 second. We're going to take a look at how it looks like after 1 second. Right, so after 1 second, it is kind of rotated, right? We can clearly see that it's kind of rotated. And those are different values. In fact, what if I do the following thing? If it's greater than 1, we're going to simply subtract 1, just to see what's going on. Right, so this is like 0, and those are different values that should give you like different things. Right, and so, as you can see, this one is bigger, so that means the closer it is, like, yeah. That's kind of strange. Okay. So maybe we have to do an opposite thing. We have to do an opposite thing. Let me see. Right. So this is Z, we do that, and in here we multiply it. So that means the closer it is, the closer it is to the 0, which means that we probably have to do something like this, right? So do the opposite thing, and then we're gonna do FF000, and we're gonna merge it with something like this, 1.8, 2, 3, and this is the original value. So essentially, we're not gonna play with alpha because I don't think it's particularly useful. We're gonna more play with the actual specific color. So what do we have in here? Semicolon. And boom. Okay, this one is rather interesting. So let's go to a 800, 600. So it's actually producing something. And I think, yes, this is what I was talking about. But why does it have this greenish tint? That is so cool. Again, we're using Z value, the actual Z value, to shade the triangle. And all of that without OpenGL, by the way. This is so cool, I really like that. The problem is that I don't understand what the hell is wrong with the color. Right. White, it's greenish. It's just so weird. So this is 1 byte, 8 bits. So what if I don't do it like this? This is so cool, yeah. So here, this is incorrect. The closer it is, the darker it becomes, which is obviously incorrect. So we probably have to do an opposite thing. Alright. So, and it feels like, to some extent, it becomes too big. Right, and if V is greater than 255, I think we have to set it to 255 just in case. Yeah. Yeah, that's so cool. And why is it green? I still don't understand. Because this is a single byte, right? Then by 2 bytes. Ah, I see why. Because like this. Yeah. So you don't have to. There we go. This is what I wanted. Yes, this is perfect. Yeah. That's so cool. And now, okay. So this is Z and everything. So this is actually Z minus 1. Alright, and if we open it up, so this is plus, which means that we can just do 2. There we go, 2 sort of like move it around. And then I want to do uint32 color. So I have to take this thing from the color buffer, right, from the color buffer. And now, right, I'm going to do 3, and yeah, this is the final color. This is the final color, and I want to blend it. Let's blend color. Oh, that means I don't need this thing, so I just only have to do it like this. Alright. So what do we have? It has to be a pointer. Yes. So it's kind of fucked up. It's really weird that... Because Z minus 1, right, so then I can just use Z. Okay, so maybe I don't have to do that, I can just like use Z then. Or maybe it's kind of difficult to see. Yeah, that's what I wanted. So as you can see, a certain leg becomes further away. Right, it becomes further away, and essentially that's what you have. You know, the shadow that we use in here, it's black. What if we make it the same as the background? This is what's interesting. So what's the background color? What we fill our thing is, so this is what we fill it with. That means I want to do X 80, 80, 80. There we go. So this is shadow. That's very cool. Interestingly, we can try to, for example, make it red, and it's going to feel like a red, how to say that, like a red fog, but nah, because the triangle is so rainbowish, it's not clear how it goes. So I think just making it black makes it more obvious. Anyway, right. So this is us using the Z buffer just to shade this entire thing. Right. But again, as I already said, we can use the same thing to actually filter out some of the pixels. Right. So if we have two Z buffers, we can construct the ultimate Z buffer that, actually not ultimate Z buffer, but ultimate color buffer that contains some pixel of some triangle and some other pixels of another triangle. And then, by the way, we can still use that Z buffer to shade things around to give it sort of a volume. Volume. We can give it volume. Volume. I think this is how we pronounce that. And volume, yes. And I was ashamed of my Ukrainian pronunciation. My English pronunciation is even worse. Right? At least my Ukrainian pronunciation sounds like Belarusian, right? Or probably not, I don't know. Anyway. So. I can understand your English, so it works. Thank you. I really appreciate your kind words, kind sir. Okay, good. So, let's try to actually combine two triangles together. Again, so if I enable the second triangle, right? So let's see what's gonna happen. Oh, so this one is supposed to be C. Let's see. Cool table in the background. Thank you so much. I think it's also from IKEA. I can sell this furniture in Russia for so much money. Holy fucking shit, I'm gonna be freaking rich. I'm joking. I'm never gonna be rich. Alright, so vector 3. I just want to extract those things to separate variables. Rich. Vector 3 with 2. Vector 3 with 3. Okay, so we have that. So I have a feeling that we need to have two Z buffers, actually. Or... So my idea was the following. So I was thinking that we're gonna render the triangle into one color buffer and one Z buffer, and then the second triangle into another color buffer and another Z buffer. And then we're gonna iterate and we're just gonna combine two Z buffers together. You know what I'm thinking? Can we... we probably can. So I was thinking maybe I can do that on the level of this function, so it would actually check whatever values you have already in the Z buffer and would sort of like filter out the ones that are closer or further away. But you also have to make a decision upon when something is closer or stuff like that. So that means you still have to have like two color buffers. Yeah. You have to have two color buffers, at least with the API like this right now, right? So let's actually do the following thing. I'm gonna have pixels 1 and Z buffer 1, and then I'm gonna have a second thing. We replace 1 with 2. There we go. Cool. So, and it compiled somehow. Why the fuck? Oh, this is because I'm a bebegger. I'm a bebegger. All right. So now, this one is going to be OC1, ZB1. I'm going to copy paste this thing to here, and I'm going to replace this thing with 1, 2. This is not particularly what I wanted, but anyway. Cool. So this is OC2. Did I already modify some things in here? No, it's got to be ZB1, ZB2. Right. And I can probably copy paste those things. Right. So now we have two separate things. And now we need to start merging two Z buffers together. Right. So let's actually merge two Z buffers together. Okay, I think the time has come. There you go. Alright, so we're iterating through all of these things, so we have to have Z1, which we're going to take from the first Z buffer, and Z2 from the second Z buffer. Right. How we are going to approach all of that? Right, so how are we going to be approaching all of that? I suppose if Z1 is less than Z2, the final color is the final color is going to be the one from the first color buffer. Right. So, and we're going to use the first color buffer as the as the final thing, because this is what we're going to return. So that means we have to look for thing that is greater. Right, we have to look for the thing that is greater. And if Z1 is greater, right, that means we have to assign Olivet's pixel OC1 next to y, and boom, let's do -1, put it like that. And I'm not going to do any shading right now, I'm just going to try to combine these two things together. It's a very simple logic, right? It's a very simple logic. It's simply just checks if one Z is bigger or smaller, that means I'm just using a different pixel. Right, so that's the whole logic. And let's see what's going to happen. Is it going to combine those things properly? It didn't even compile yet, so we'll have to just go through the compilation errors very carefully. I'm not quite sure what the hell is going on here. What else do we have? Okay, so there's the last one. This is Z2, Z2, and the drum roll. And we can't see shit in this mist, which is rather weird. Right, we don't... Oh, I see. So this one has to be... Okay, I fucked up a lot of things in here, right? ZB1, ZB2. Let me go through all of this. ZB2, OC2. OC2, ZB2. ZB1, OC1. Okay, so that should be it. That should actually work. Right, that should actually work. Let me see, and it kind of works, but it produces really weird results. So let me maybe try to use a different direction. Right. Let me try to use a different direction. Okay, it kind of works, but it also you can see kind of this line. It's a really weird line. It's a really weird line. And the reason why this is also weird is because we have a projection. Right. So essentially, when you project a point from 3D space onto the screen, the Z value on the screen is not interpolated linearly. It is not linearly interpolated. Right, so let me open the document. So this is a very centric. Actually, we have to take a look at the 3D projection. Right, so if you have these two things, the Z value between two of them, it would be kind of nice if maybe P2 was slightly to the side. I wonder if we can easily do that. So where is P2? P2. They are literally on the same thing, and I wonder if I can add like a half of this entire thing and then do PDF later 3D projection tech. Right, and I wonder if it's going to work. Yeah, it definitely didn't work. Okay, so I'm not gonna even try. But anyway, so after the projection, the Z on the screen is not linear. We have to interpolate 1 over Z. And that is going to be more correct. So let's give it a try and see if it's actually going to fix the problem or not. Okay, how are we going to be doing that? Like, we literally have to divide it by 1. Right, since when we project, we divide by Z. Right, you see, we divide X by Z and Y by Z just to project it on the screen. When we interpolate Z, we have to interpolate 1 over Z then. Right, so let's see if it's going to work. So it's going to be 1 over Z, 1 over Z. And we have to keep in mind that in the Z buffer, we actually store 1 over Z. 1 over Z, 1 over Z. So we'll probably also have to change the sign of comparison, but it will depend. Because comparing 1 over Z, you have to actually flip things. Right. So triangle 3D SDL. Let me see. Look at that. Holy shit. That is so cool. Holy fuck. This is like a proper OpenGL, but it doesn't use OpenGL. This shit does not use OpenGL. It just doesn't. That's so fucking cool. I love it. Yo. Yo, 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 yo. Yep. Cool. So, and on top of that, let's try to apply the shading as well. Let's try to apply the shading. So, I think I'm gonna do it like that. Okay, so float Z1 is gonna be equal to Z2, right? And here, I'm gonna replace all of these Z with Z1. Alright, Z1, B, and then this is OC1. So on top of like combining two triangles together, we're also gonna shade the entire thing. Right, so let's try to shade the entire thing. So we're applying 2 techniques simultaneously. Did it work? I think it didn't work. I can't see shit in this mist, so I think it didn't work. Alright. So it was black. So if I do not do this thing, oof. Ah, yeah, I see. So we have to do, we have to convert it back. Of course, we have to convert it back. Otherwise, it's just not gonna work the same way. Right. So let me see. I'm in the wrong place. Yep, and there we go. So this entire thing is also shaded, and it's a bit slower than usual, but yeah. Is it clear that it is shaded? I think this is super cool. Oh fuck. Maybe we should not shade it from 0 to 1, right? Maybe we shouldn't do that. Because... So, the problem that I see is that the center is too dark already, right? The center is kind of too dark already. Maybe we should kind of shift the entire thing. You know, yeah. Okay. What if I make the triangle slightly bigger? Is it possible to make it bigger? How do we achieve its size? So it's a 0.5. We use quite extensively this command, 0.5. So x minus 0.5, I wonder if we can assign it to something like 0.5. Right. What if I... So this is half, but this is also z. If I put t in here, and also t in here, right? Okay, now, what if I make it 75? Is it gonna be better? Yes. And it's actually slower, look at that. But also I'm streaming right now, so on the stream it could be kind of, yeah. But I don't even try to optimize anything, so this is quite important, right? So what if I apply a tiny bit of optimization on this thing, right? At least for this one, O2 for instance. How about O2? A little bit of O2. It's actually way smoother now. And this is still no OpenGL. Holy fuck, this is so cool. My god. I'm so proud of myself. This is so cool. And you know, the coolest part is that I understand the math behind it to the point that I rendering this pixel by pixel, not OpenGL, not just using tutorials or anything like that. I understand it. That's the most precious thing in software development, in my opinion, is understanding this thing, so it's not a black box anymore. Right. So, yeah. Orbital cam. Yeah, so changing the camera also will be kind of cool in here, but it's gonna be effectively just changing the whole thing. Yeah. So freaking cool. And you know what's cooler? We can try to compile it to WebAssembly. Right. So let's go to, yeah, so let's uncomment the WebAssembly thing. Right, so while it tries to do something that is not available there. Okay. Cool. Now I'm gonna start the server, HTTP server 6969. There we go. We already have a buffer running there. So what is it running? I'm not sure. What is it running? So let's try to run this thing. Localhost 6969. Let's scroll down. And this is what we have in here. Interestingly, they all feel a bit slow. Probably because I'm streaming and there's like a lot of them. So let me go ahead and say, okay, we're not optimizing for size anymore. Optimize for the performance. O2. So let me now go localhost. So I probably want to refresh the entire thing. Oh yeah, my laptop is also kind of slow right now. Okay, I wonder if I disable some of the demos. So we have triangle 3D. Why do I have two squishes in here? That's kind of weird. Right, and I'm also gonna say, okay, do not start these demos. Okay, so there was only a triangle 3D. So it also works in WebAssembly, right? Can you make one triangle half transparent? I can try. That's a good question. So let's actually see. What's the half of this? Well, I'm probably not going to do half, but you know, I can make something like AA. Is it going to be good? Yeah. So we don't blend those things together. That's why they don't really work like that. which also means that maybe we can try to approach it like this. Obvious blend. Thank you for the question. It's actually, you know, demonstrated that there is a little bit of a problem in here. Alright, so let's try to fix it. Alright. So, and in here we just do the opposite thing. Yeah, something like this. Is the alpha at the end of the hex? Yes, it is, because it's a little ending. Right. Still kind of difficult to see. Right. Maybe I'm going to change this thing even further. Let's actually make it 0x, I don't know, 15. Oh no! What the hell is that? Probably because of the shading. Let's actually try to not do the shading. Nah, it doesn't work. I'll look into that a little bit later. Thank you for the question. But right now, I don't think I want to look into that. Because I'm already streaming for 2 hours, I was about to finish the stream, so I'm gonna look into that a little bit later. Alright. So... So it's just a matter of how we're blending things together, I suppose. But yeah, that's the result of today's stream. I'm looking forward to look into how it works when I'm not streaming, right? Because when I'm streaming, the stream consumes too many resources and stuff like that. So, does anyone have any questions? So, while people are asking questions, so let me quickly... you don't render a color canvas too, so second blend doesn't work. Yeah, probably. So it's probably it basically boils down to like little details on how I exactly do that. My goal was right now to just like implement the general idea of the Z buffering, so to make the Z buffering possible, and how we combine all the things that can be changed later, right? So yeah. Alright, so let me commit whatever we have already, right? So because I think it's actually really cool. 3D projection, I'm not sure if I need to commit that. I don't think I modified anything. I think we need that. And yeah, so there was 2 squishes. I don't think we need that. So if I support SD, oh okay, so I'm just reading random messages from the chat. You know what I wanted, by the way? I wanted to check for the terminal. Right, so this thing should work in the terminal as well. This thing should work in the terminal as well, which means we can do something like triangle 3D terminal. There we go. Yeah. So kind of works, I suppose. It's rather interesting. But yeah, it's pretty cool. It's pretty cool. I really like the shadow. Man. That's so cool. Or it does look like Arch, yeah. So it's like an Arch logo. Anyway, so let me uncomment all of those things and let me actually recompile everything. So let's just recompile everything, make sure that we didn't break anything. 3D Arch logo, yes. Do you need RTX 4090 to render it? No, you don't. In fact, I'm not even sure you need GPU at all. Well, I mean, you still need some sort of GPU to print on the screen, but to output on the screen. But this thing is done completely on CPU, right? So all the pixels are generated on CPU. And I also want to run the tests. So let's run the tests, and that seems to be fine. So we have a bunch of tests in here. So actually, we have a lot of like different tests. This is one of the tests actually.